Hello. Hope you can see me because I am the shortest one here. So thanks for the platform CEO team. I appreciate that. And so how many of them worked in Kubernetes before? Oh, that's nice. So I think I'll be the least smart one in the room. So just bear with me for the whole section. We have demo sections as well. That's me. I'm a mom to 9 months old baby. Like Simon, we are in the same age. Okay, and mom and enthusiast, which normally not everyone likes, but yeah, I'm definitely a and DevOps engineer, but I began with the system administration background and then slowly moved to the evergreen technology DevOps. That's all about me. That's me before in my prime era. Before me as a mom, now it's all changed. So these are my agendas for today, and we have 5 topics we will be covering all hands on and few topics, but I thought it will be a very relevant one. So we are talking about one major topic, which is API server crash due to the excessive CRD. CRD stands for Custom Resource Definition Rights. I'm pausing for a moment. Hope you can see my screen because I'm standing here. Is it okay? Because I'm short, it will be fine, right? Okay, so we have this section. And yeah, this is the explanation. It's all about API server crash due to the flooding by malfunctioning controller creating too many custom resources. So what is this? That means if you are working as a DevOps engineer and one day your API server stop responding, that means even you can't just enter a kubectl command. That means the screen all stuck. So where will we go? Any comments from the team? Where will we go if we can't find any kubectl command or the API crashes? Any comments from the audience? What will you do? Any monitoring? Anywhere? Okay, so who all use the Prometheus and Grafana? Okay, oh, definitely Matt is the smartest guy in the room. He always has some solution everywhere. So I will go and check the Prometheus and see, okay, what's wrong? What's wrong in the API server? Why it's not responding? And so I don't know in which all firms we use customized controller, but in my projects, in my firms, they all use the custom controller, but it's not all safe all the time. So there will be a spamming controller that can cause a buggy API resources. So what we can see, a 504 gateway error or timed out kubectl commands, and yeah, we can definitely see some alerts in our Prometheus. Okay, let's dive into the demo session if you are interested. I think I can give some demo in the next one. So this is just a similar scenario which I am going to talk about. So this is one scenario, exactly same thing we are talking in the next one, that is API server high latency due to event flooding. So who all tried the hacking one? Anyone tried to do the hacking in the real life as an ethical hacker? Anyone in the room is a ethical hacker? No? No one? Wow! That's that's surprising, because I always had this mindset that, oh, what if I can hack that password? Okay, it's interesting. So I'm going to do one live hacking here. So I don't know if anyone is inside this room interested in the hacking, but definitely it's not that much bigger one. So if you can see, you can see my letters in the screen. No, no one can. Okay, I don't know if I can. Okay. Ooh, I didn't know that I can just pinch it. Okay, that's cool. Okay, so I need to. So this is my GKE cluster which I just set up for the demo purpose. Stick with me. It's reloading. Okay. It's slow. Okay, cool. Uh, so what we are going to do is, we are just going to spam our API master server by using just list commands, list ports. Okay. So you might be wondering, does a list ports command can spam our API server? The answer is yes, because if a action that can happen 100 times, that can also break our API server. So I have one few demos coming. So these are my YAML file. I hope you can hear my voice, right? So because it's very hard to type and talk. So sorry. Yeah, no, it's okay, it's okay. Thank you so much. Ooh, that's okay. Okay, so I can show you one file which I am using for the spamming. So just stick with me. So okay, so you can see this looks like a simple script, but if you come down and see this image which I am using here, so this is okay. I have this cool stuff which is given by Simon. So let me see if I can, yeah. So you can see my image, right? So this is the spamming script which I used. I can show you that, but don't use it at home, because it's going to be use it on your script. Sorry, on your risk. So I'm just picking my, okay, it's not there. Let's leave it. Okay, I'm just using my own image here that I use for the spamming. So spamming in the same, I'm spamming the API whole master with my script, and how we are going to find out. That means if any actions happening in the kubectl events. So I'm just trying to apply this in the server. So this is the simple command that we use daily basis, kubectl minus apply, and my script deployment. Okay, cool. So this will spawn my ports. You can see my screen, right? So okay, the command it's kubectl minus f apply deployment .yaml. It's not running, so you need to run kubectl apply deployment. So it's not running. Okay, I can see. Sorry. Oh, thanks for the, oh, you guys are really listening. Okay, kubectl minus f slow. Wait for a minute. Okay, I do have live recording as well, but let's see if it's going to be, okay, is it too low? Okay, it's an authentication error. Why no one noticed it? Yes, yes, exactly. So this is like, I need the authorization. Okay, just a second. I need to reconnect, I think so. Okay, so we'll do one thing. I have this one. So we tried until kubectl apply minus f, right? So this is a recording I have done. I know that it's definitely going to break. So what is going to happen there? So we have applied one spamming script. One second. Okay, so yeah, cool. So this is the output. So we have this pod running that's called spam controller. I hope you can see it's stating us running, and what it's doing that, it's listing all the ports in the kube API server. Just you can see the API call that's called found 27 sort. So what it's doing, it's just listing all the ports, and now what is happening that there is the whole spamming situation happening, and we are getting all kubectl API calls that the events are flooded and the API is down with kubectl timed out. Okay, so for this situation we will get some alerts in the Prometheus, and we will eventually look after the logs of the kubectl top ports command, so which we normally find, okay, which are the top ports we are getting with high load situation, and that's how the troubleshooting works. So anyone have question how we can find spamming in the server, or from where we can find, and how we can mitigate the issue? Anyone have any doubts? You can ask me. No? Is it self-explanatory that I am explaining how it's happening? All good, right? Okay. So we will move on to the next one. So this is okay. Scenario 2. Okay, so we already explained these points. That means if you are seeing any API latency spikes, we can go and check the dashboards for the slowdowns, kubectl timeouts, and there's one more scenario which I highlighted. That means create kubectl get event sort by metadata creation timestamp. That means if any resources are creating that by the spammer, and we can just filter by using the so we can find it from here. That means, is it coming? Okay, no. Okay, so we can find it from the creation timestamp for the masking event spamming. So I just done a list port spam. So that's not supposed to be the same thing every time, right? So it's like a different things every time. So you can see a creation timestamp in the kubectl events. As far as I know, kubectl event command only leaves the creation events. There is you can't see the list ports or anything which lists the resources in the kubectl. So it's just the creation events you can see in the kubectl get events. So I don't prefer kubectl event for the monitoring purpose, because it's always lists less information. So just always rely on the better one, that means Prometheus, which have the better metrics, and yeah, definitely you will get the fix and workaround during the after you find out that it's spamming what's going on. And definitely, yeah, we can move on to the next topic. I will come to this later because it's a basic one. So this is I think most of them in the room could see in your real life. This is like building efficient bloater versus optimized Docker. So I'm just pulling a real life scenario here. Think of a person, a fatty person who are in the room or in the anywhere. Okay, so I'm just making that person into a thinner one. That means a lean person, like by using optimized Docker image. So what are we doing here? That means we are building efficient and secure Docker image by using the layers technology. So what do you mean by layering? That means if you see this picture, so you can see the layers. That means stage 1, stage 2. So okay, I'm talking about this second one. So if you can see this first one, it's just a normal traditional Docker image you can see. That means that's the one which I use for more than in the 4 or 5 years in my life. Then I realized, okay, why it's failing all the time if it's fatty. That means most of the libraries are always not needed after the installation. For example, if I'm using a command called run npm install, after that why I need those fold library is not needed every time, because we are not realizing what the libraries are doing. So what I found out that, so if I can uninstall the libraries after I install, then I can just make the image slimmer. That means the more lightweight image which I can rebuild in my containerization technology, and that will save a lot of time, because most of my daily works are like I need to roll out and restart the command more than 5 times in a day. Okay, so 5 times in a day. So what I will do that, I will just make the image more lighter version, so that I use this one and it saves a lot of time. So we can definitely try these images. I do have a demo for that. So stick with me. Yeah, this is the fattier image I had. You can see my screen, right? Okay, so I just created Docker image which is having 1.5 GB size. You can see the image with the tag v3 which I push into my personal Docker repo. So this is a demo Docker image which I just pushed. So you can see the pushing screen, right? Pushing 422 out of 1.5 GB. So this process itself took more than 50 minutes to complete. So you can imagine 50 minutes of a developer or DevOps guy in a day, and he's doing it for more of 4 or 5 times in a day. Okay, so this is my Docker Hub which I pushed. So it just to show you the compressed size of a Docker container, and by using this container I am going to deploy one container plus one image which is the optimized one. So you can see two YAML files which I am using with the container, fatty container, and with the lighter one. So this is just for just for displaying what the YAML file looks like. Okay, this is the one with the fatty image. You can see demo fatty images. So this is a container. So it will take some time. So for this demo, what I have done that with the Google Container Engine, because it was autopilot one, I believe the autopilot mode. So it was failing because there is no resources allocated. So you can see my image with the Docker optimized deployment file. So what it does that, okay, let me hold on for a second. So I'm pausing this here, and what it does that, it will deploy the container with the Docker optimized image. That means I have the image which I shown just fine at the back. Okay, this is the image. So I use this principle. That means I just used to build with, okay, this is a normal traditional one. I just made 2 stages, that is build stage and package stage. So you can see the Docker image itself self-explanatory. You can see I have removed a few images and I think there is no remove command here. Let me grab some from my page. Okay, so yeah, so you can see the removal of unwanted libraries here. So you can see this from my screen, right? Yeah, so I removed varlib illicit. So this was taking more than 1 GB. So I just removed it because we don't need it. I realized after 4 years of my DevOps career. Okay, so yeah, this will definitely make the app running. So yeah, so back to our video. So I'm just fast forwarding because it will take some time. So just a second. Yeah, so we can see there is 3 containers in the server, and one is optimized, which takes only 79 seconds. I try to create the fattier one, fatty image one, which is the first container which is still creating, and it never created, and it you can see it will come up with the error. So just a second, because you can't screen because there is a pause button. Okay, can you read this? Out of 0 out of 2 nodes available to insufficient memory. Yeah, that's what happened. Because most of the time the fatty images will cause container creating failed states just because they are having unwanted libraries. So the moral of the story is do not use fatty images with the unwanted libraries. So make sure you have layers of the, make sure you are following these layers in your strategy, because it's a very basic thing, but it will definitely going to save your time. Yes, so moving on, we will have one more another topic which is I think pretty much relevant. Yeah, so we have, okay, so this is also one pretty basic thing, that means ensuring application readiness with init containers in Kubernetes. So why do we need init containers? So any DevOps guys, Kubernetes guys in the room? Why do we, yeah, of course.
So one of the reasons that you could use init containers would be if you have something like an image that doesn't involve code directly, such as like a database, for example.
Okay.
You could use the init container to make an API call to the secrets manager that you might use,
Yes.
pull the Postgres password, expose it as an environment variable,
Okay.
and then that would allow you to just use the image of Postgres.
Perfect. That was so comprehensive. So definitely yes, ensuring application readiness with init containers in the Kubernetes, very basic and very relevant answer. And when we face any issues in the init containers, so what will happen? That means what will happen to the main container? So it always fails, that right? So I just created one demo, but I think he answered it perfectly, so I'm just skipping that. But coming to the main point, so if we have any application, that means if, let's take an example here. So if you have a web application plus if you have a database application or anything which needs the main container up and running, we always keep it in the init container and it will start before that. That means if I have an web application that needs the database DB, and what we do then, let the init container run first, and then only we can go with the main container. And if any errors come, what will we do? How will we troubleshoot? So if you can see the main container is stopped, and what will we do? Where will we troubleshoot? Is it in the just the main container logs or anywhere else? So any idea from the team? Any idea? Well, from how we troubleshoot the init container port? Any idea? No? Okay. So we always go with starting with the logs. That means I have a demo. Just stick with me. Okay. So yeah, it's coming. So we always have, so this is just a normal container which I deployed, this is the Nginx container. So I just wrote this one, okay, just post it here. So this is my init container, and I wrote this for, just for printing out something which is not relevant here, but normally we can say that, like he said, we can call some API calls, we can connect to the database. So these are the things, and we have the main container, which is the fail main container which I wrote here. It just displays the exit command just for the demo purpose, and if something happened here, you know, it will completely fail the main container. And how we can replicate it that? So we can just go to the logs and see. Okay. So if you can see this container, so I intentionally wrote the script to fail the init container just because we can see it's not coming from the main container image, and you can see this container just failing because of the init container error, and we can just track it by using the logs command, and always use the kubectl logs minus c init container name and the main container name. So this is just a troubleshooting one. Okay, and we are almost here with the main log. That means we fix. I'm just fast forwarding. I will give you the context of the issue. So the issue was, I just initially failed this init container, and after I fix the init container issue, then I can see there is issues in the main container, and I fix the main container issue, then it can run. So moral is always look for the init container issues before you go with the main, because I done this main many times without realizing it was coming from the init. So that's it for the demo, but I try to cover the 4 main relevant repeated issues. So yeah, definitely reach out to me for the more troubleshooting steps, and this is me. You can definitely reach out to me. I'm not master of it, but you can definitely ask me any time if you stuck up within the issue. Always Matt there. He's the smartest guy. Definitely, he's also there to help you. But yeah, that was amazing to share a little bit of knowledge. It's not whole issue, but I thought of sharing five important topics which I always had faced in my whole career. But yeah, I will share with you your team in the comment section of the meeting. You can definitely go and check it out, and also the demo on my GitHub page URL. So yeah, if there are any questions, you can come on to the LinkedIn, because we are running out of the time. So Matt is here to stop me out in the middle of it. Okay, so yeah, definitely reach out to me for any help. That's all. You have any question? Please ask. Feel free to ask.